Okay, in this video we're going to talk just very briefly about interval notation, which is one way of expressing answers that gets introduced in Unit 1 of Math 3. Here's the kind of questions you might see asked where students would be asked to use interval notation in the first couple units of the course. Most commonly in Unit 1 they're asked to state the domain and range in interval notation. There are a few spots in the second part of the chapter and on the test where they're asked, given a certain interval, this would be from -6 to 0, including -6 and including 0, what type of function is represented? And the answer that we're asking them for is a quadratic or a linear function or an exponential function. As we move into Unit 2, they'll get more questions about graphs of functions. Where is f of x positive? Where is the graph of f of x increasing? Where is the graph of f of x greater than the graph of g of x, or the y value of f of x greater than the y value of g of x? And so those are the kinds of questions that students are expected to understand, questions written in interval notation, and to give answers in interval notation. So if you haven't had a lot of experience with interval notation, or it's been a while since you used it, basically there's just 3 different ways of expressing answers. This graphical way we've seen on a lot of released questions from Smarter Balance, so this is a way that your students should definitely be comfortable with. They are asked to show graphically the interval where f of x is greater than g of x, and they actually put points and slide on the number line to connect that. So graphically, if I wanted to show that I wanted all the points between 2 and 4, not including 2 but including 4, I would do it like that. In inequality notation, which you're probably really comfortable with, I might have something like this. And in interval notation, it would look like this. So the parentheses here is put when the 2 is not included. There's no equal sign. It's an open circle. And the bracket is put when the 4 is included. And this says the interval between 2 and 4, all the points between 2 and 4 are included in the answer, and 4 is also included in that answer. Okay. So a couple examples, places where students mess up when they're first learning interval notation, I wanted to show you. So here's just a few examples, and then we'll also look at places on the worksheets where they're asked to use interval notation. So usually when it is an interval where it's between 2 numbers, students do not have very much trouble, but I would suggest that interval notation is very easy to go from graphical to interval notation, but sometimes it's difficult when they're going straight from inequality notation, especially as we get down to these later examples. So I always have them move to graphical and then to interval notation as a good training. So graphically, this would be an interval that started at -1 and ended at 6. -1 would be included, 6 would not be included, and a lot of you graph this different ways. You might be commonly use something like that. I usually just have it right on the number line, and that's just totally a matter of choice. Sometimes my students will use a highlighter or something to show that difference. So that is the graphical representation of this. It's good to practice this also because Smarter Balance, this is what they're going to have often for the answers. And then from this, they're going to give the answer in interval notation. And so interval notation is always written in order from smallest to largest, and so you're always going to start with the first point that you get to. This is the thing kids mess up sometimes, particularly when we're talking about y values. So from 1 to 6, I'm going to include the 1, and I'm going to not include the 6. There is a problem if both of these are open, that the interval will look just like a point, and I tell the students that they have to tell by the context of the situation whether this, if this was written, is a point, -1, 6, or is an interval, x values from -1 to 6, not including -1 and 6. Just like the words tear and tear, they have to tell in context when they're reading. In interval notation, sometimes they have to tell by the context of the situation which thing we're talking about. On the next one, if we looked at that on graphically, we would see 3 is a key point, and I would not be including 3, so I have an open circle, and I want all the values greater than. So I start with the smallest number, so I'm going to start with 3 in interval notation. I'm not including it because it's open. And there is no top number here to put, like there was this nice stopping spot. And so we use the symbol infinity. As a matter of fact, for some of my students, they like to write infinity right there, so they have that same feeling of sandwiching in the interval, even though we never will actually get to infinity. Because we will never actually get there, infinities always are closed with a parentheses. You never include infinity because you don't get there. And the third problem I wanted to look at was the one that causes the most trouble. Graphically, we're going to start at 3. It will be included, and now I want all the values less than 3. And when we wrote it in inequality notation, we wrote down x first and then the 3. And here from the graph, 3 seems like the really important thing. So students tend to want to write 3 first. But remember, we're always going to go from lowest to highest, and so lowest we could put negative infinity. This is the lowest it will go, and this interval is actually negative infinity to 3, including 3, because there's a solid dot. And so I would say when things start with a less than, often kids will put these in the wrong order. It always has to be from smallest to largest. Let's look at a few spots on the worksheets that ask for interval notation, just so you can see where those come from. The first one I'm going to look at, the first time you run into it is in worksheet 2. It actually says use interval notation right here for problems 3 through 6 to state the domain and range. So you get inequality notation for the first couple, just something they're more familiar with while they're kind of grappling with the idea of domain and range. But now by the time you get to 3, you're going to want to be writing domain and range in interval notation. And I'm going to skip, well, we'll go ahead and do 3. So 3 would be a parabola. I would think that it is shifted to the right one because it shifts opposite the sign when it's inside, so it would be like this. And I will talk later about tricks for graphing these if you want them. This would be the parabola we're speaking of. It's facing up because there's a sign, the sign in front is positive, and this is the parabola we're talking about. So as we look at that parabola, visually we should be able to see the domain and the range. And as this goes, the x values are the domain, and this is going to just continue open up and up. No matter what x value I put in, I will be able to get a y value out, and that tells me that the domain is all real numbers. Now if we want to write all real numbers in inequality, there's not really a good way to do that. And in fact, we write the words all real numbers, or we use that symbol that you might have seen. But in interval notation, all real numbers is written from negative infinity to infinity, because the lowest value on the x-axis that we're going to use is negative infinity, and the highest value we're going to use is infinity. We're going to do all of those x values. For the range, we are not going to use all the y values. The lowest y value we're going to use is 0 in this case, and the highest y value we're going to use is positive infinity. So this range is 0 to positive infinity. Now you never can get to positive infinity, but this does in fact get to a y value of 0, so I'm going to include that. And so that would be a place where you're using interval notation to express. Really common, because we read top to bottom for kids to want to say infinity to 0. And so you have to remember you're going from smallest to largest, the smallest to largest. That's kind of counter their natural tendencies on something like that. So that's what's going on with the interval notation in this chapter. You'll continue to see that in several places. It happens in worksheet 4. Worksheet 5 is a little bit more interesting. So worksheet 5, there's a whole video on worksheet 5 and 6 working our way into piecewise functions. Worksheet 5 has a lot of very interesting graphs, and so for instance, this graph, this worksheet has them eventually graph this function, and I'll explain more what we're doing with all of that. But as this turns out, this is a parabola, and it's going to only be when x is greater than -2. So they have them figure out -2 plugged in is 4, and you can actually plot that point, 1, 2, 3, 4. And as we keep going, we're going to get this parabola. And I'm skipping explaining all of this. But right here is a wall that we're not going to pass. There will be no graph when x is less than -2, only greater than. So as I graph this, it's going to start here. It's going to go on up like this. And I need to realize that there's no equal sign here, so that actually means that there would be an open circle right here. It wouldn't actually hit at -2. Okay. And so if I'm only going to graph when x is greater than -2, I would have an open there, and it would keep going. So when you do the domain and range of this one, this is a little bit more interesting. The domain and range of the graph, of the restricted function. Now the lowest x value that I have is -2, and I don't really have that, so I have to put parentheses. But it goes on forever on this side, so it will go to infinity. And the lowest y value I have is 0, and I do actually get to that spot. And the highest y value is positive infinity. And so they get more interesting. You don't just always have all real numbers for the domain as you go on to these restricted values. And so practicing the domain and range when it's a little bit easier visually, getting them to visualize that domain and range will help you as you go on. When you get to the reviews and on the test, you will start to see problems where they'll ask a question in interval notation. So you might have been able to avoid interval notation to this point and having them answer in inequalities, but on the test you will see that they are given interval notation and have to understand what that means. For the interval from -6 to 0, state what type of function is represented. So they need to know that this is x values. And in fact, all questions that you answer in interval notation are answered in x values because we put x values into a function, except for the range, because the range is about the y's. So when you see an interval, unless it's about the range, this is using x values. So from -6 to 0, from this part of the function, it appears that I have a quadratic. So that's how that went. As we go on, in Chapter 2, there's much more with interval notation in terms of questions and understanding and expressing their answers in interval notation. So this chapter is just kind of an introduction to it, being able to understand something, a little bit of practice with the domains and range, and we'll use it more in the second chapter. So use this chapter as kind of a little intro to it. Don't make a big deal about it. It's not a big deal. So good luck with that, and I'll see you later.